everyone! We are the researchers of Group 1. My name is Rowella Jane V. Fernando.
And I am Aya Margaret C. Porto.
And I am Chrissy May Albarazin. And in this video, we are going to tackle about a type of inferential statistic named Pearson correlation coefficient.
The Pearson correlation coefficient is the most common way of measuring a linear correlation. It is a number between -1 and +1 that measures the strength and direction of the relationship of the two variables. When one variable changes, the other variable changes in the same direction.
The strength of relationship can be anywhere to -1 and +1. The stronger the correlation, the closer the correlation coefficient comes to +(-1). If the coefficient is a positive number, the variables are directly related. As the value of one variable goes up, the other variables tends to do so. Pearson correlation coefficient, or also known as Pearson's R, was developed by Carl Pearson in 1948 from a related idea introduced by Sir Francis Galton in the late 1800s, and for which its mathematical formula was derived and published by Auguste Bravais in 1884. The naming of the coefficient thus is an example of Steiger's law. In addition, for being the very first correlational measure to be developed, it is also the most commonly used measure of association.
6 people have different ages and weights in the given. Calculate and find out if there is a relationship between these people's age and weight using the formula of Pearson correlation coefficient.
And now we're going to move on Pearson correlational coefficient formula. So the formula is R equals and summation of xy minus summation of x times summation of y over the square root of n summation of x squared minus summation of x squared times square root of n summation of y squared minus summation of y squared.
If R is equal to -1, therefore, there is a perfect negative correlation. If R is close to 0, therefore, there is no linear correlation. And if R is equal to 1, therefore, there is a perfect positive correlation.
So first step we're gonna do is going to get the x squared. To get the x squared, we are going to multiply this number by itself. For example, 18 squared is equal to 324 and 324. The next step is going to get the y squared. To get the y squared, we're going to multiply this number by itself. And 2025. Next step, we're going to get the xy. To get the xy, we are going to multiply 18 times 45. And the answer is 810, and so on. And to get the summation, we're going to add all of this. 18 plus 22 and 29, 17 plus 33 plus 24 is equal to 143. And that's how we get the summation. And so we're going to move on with our last step, which is solving our example. We are going to write first our formula, which is R equals to n summation of xy minus summation of x times summation of y over the square root of n summation of x squared minus summation of x squared times the square root of n summation of y squared minus summation of y squared. So what we have to do is substitution. We only have to substitute our n, which is the number of our values, which is 1, 2, 3, 4, 5, 6. So we have our sample 6. So n is equals to 6. Summation of xy, we have 7,505. And then summation of x, we have 143. Summation of y, we have 306. And then n is 6 again. Summation of x squared is 3,603. Minus summation of x, we have 143 and squared times the square root of n, which is 6. Summation of y squared, we have 15,876 minus summation of y, 306 squared. So all we have to do is follow the formula, and then we would get the answer of 0.92. We hope that you learned something from us. Have a good day, everyone. Goodbye!